All right, so again, please do your homework. So that way we do not have to spend time reviewing the homework. But today we're going to spend time reviewing the homework. We're going to do 20 minutes tops, 7:30. We're going to move on. So let's go through it. What is JavaScript? The homework again from the developer course, the listed homework, review, JavaScript first steps. This is due next Friday, every time, next Friday. So by the time of next Friday, you have at least seven hours from 12 o'clock to your class time to take some time to at least look at the homework and be able to say, yes, I reviewed the first steps. All right, so JavaScript first steps. Welcome, high level definition. Let's start there. Actually, no, let's start here. Objective: to gain familiarity with what JavaScript is, what it can do, and how it fits into a website. A high level definition: JavaScript is a scripting or programming language that allows you to implement complex features on web pages. Complex features means behaviors. Every time a web page does more than just sit there and display static as in not changing, static information for you to look at, displaying timely content updates, interactive maps, animated 2D, 3D graphics, scrolling video, jukeboxes, etc., you can bet that JavaScript is probably involved. It is the third layer of the layer cake of standard web technologies, two of which, HTML and CSS, we have covered in much more detail in other parts of the learning area. So these are the three: HTML, CSS, JavaScript. HTML is the skeleton, CSS is the skin, JavaScript is the muscle. Let's continue. HTML, the skeleton, is the markup language that we use to structure and give meaning to our web content. For example, defining paragraphs, headings, data tables, embedding images and videos in the page. CSS is a language of style rules that we use to apply styling to our HTML content. For example, setting background colors and fonts and laying out our content in multiple columns. JavaScript is a scripting language that enables you to create dynamically updating content, control multimedia, animate images, and pretty much everything else. Okay, not everything, but it is amazing what you can achieve with a few lines of JavaScript code. The three layers build on top of one another nicely. Let's take a simple text label as an example. We can mark it up using HTML to give it structure and purpose. So we got this paragraph tag that says player one, Chris. Then we can add some CSS into the mix to get it looking nice, adding the font family, letter spacing, text transform, make it uppercase, text align, center, giving it a border, giving a background color, changing the text color here, adding shadow, box shadow to make it pop more, border radius, making it curve, padding, giving that space between the element and the content in the element, and then displaying it as an inline block. We can't really tell from this, but it's inline, and then the cursor pointer. So this cursor should change if this was an actual page. And then finally, we can add some JavaScript to implement dynamic behavior. So now we're going to have para equal document.query selector. So we learned about the CSS query selectors for a reason. With JavaScript, we're going to want to first select an element on the page. So they're going to select the element by looking for the P tag. From there, we define that and assign that to a variable that we are declaring as a constant variable. It doesn't change. And then we're going to say add event listener on it. So now the event listener is going to listen for click events, and then it's going to run the update name function. What's the update name function, you ask? It's defined right here, where we have name variable being assigned prompt, enter a new name. So prompt We haven't really played with that yet, but we're going to play with that. It should initiate an input, which means it's going to ask the user to input something, which is going to accompany with this message that we're passing along, prompt, enter a new name. Then we have para.text content is going to equal player one, and then whatever name evaluated out to be. So then in the end, we should get Chris. So let's try it out. Enter a new name. Sage. Boom. And now you see we have a dynamic way to update the name. Jasmine, Angelica. And the cool thing is, it doesn't really care how I type it. It will always fix it because they added the text transform, so that way we'll have a consistent view. So with that little example, we kind of get the idea of how all three of these things interact. We have the HTML creating the structure, the paragraph tag, the CSS styling it, and then the JavaScript looking for behavior, so that way it can implement some type of action with a behavior from the client me clicking the page, clicking the para tag. So what can it really do? The core client-side JavaScript language consists of some common programming features that allows you to do things like store useful values inside variables. That's one thing we're looking at in the above example. For instance, we ask for a new name to be entered, then store that name in a variable called name. Operations on pieces of text known as strings in programming. In the above example, we take the string player one and join it to the name variable to create the complete text label player one Chris. And then running code in response to certain events occurring on a web page, we use a click event in our example above to detect when the label is clicked, and then run the code that updates the text label, and much more. So with that covered, before we move on, is there any questions so far?
No.
All right. How you feeling, Jasmine? Everything makes sense? How
It
the
does
three
make
interact?
sense. I just have to reference it again.
No problem. As long as it makes sense. Feel free to ask questions, because we're just gonna keep going around this thing as many times as possible.
Yeah, conceptually it makes sense to me.
All right, cool. All right, let's look at this next section. What is JavaScript doing on your page? Here we'll actually start looking at some code, and while we do so, explore what actually happens when you run some JavaScript in your page. Let me shrink this up. Let's briefly recap on the story of what happens when you load a web page in a browser. When you load a web page in your browser, you are running your code, the HTML, CSS, and JavaScript, 1, 2, 3, inside an execution environment, which is your browser. Chrome, Mozilla Firefox, Internet Explorer, they all have code baked in them that allows them to run custom code that us developers give it. This is like a factory that takes in raw materials, the code, and outputs a product, the web page. A very common use of JavaScript is to dynamically modify HTML and CSS to update a user interface. So the key is dynamic versus static. Dynamic means it changes based off of input. Static means it does not change ever. Note that the code in your web documents is generally loaded and executed in the order it appears on the page. So that's a big key. Your code in your web documents is generally loaded and executed in the order it appears on the page. So if I write code above another piece of code, I should assume that that code that is written before is going to come before the code that I write after. So the same way I read from a page top to bottom, expect the browser and other things that read code to read top to bottom unless otherwise told by the specific language. But yeah, JavaScript for at least, that's the assumption. We also call that I believe, synchronous, synchronous coding. But I always get my async and sync confused. So I'm gonna have to check that out. Errors may occur if JavaScript is loaded and run before the HTML and CSS that is intended to modify. You'll learn ways around this later in the article in the script loading strategies section. Browser security. Each browser tab has its own separate bucket for running code in. These buckets are called execution environments in technical terms. This means that in most cases, the code in each tab is run completely separately, and the code in one tab cannot directly affect the code in another tab or on another website. This is good security measure. If this were not the case, then pirates could start writing code to steal information from other websites and other such bad things. There are ways to send code and data between different websites, though, also in a safe manner, and we will be covering that later. So JavaScript running order. When the browser encounters a block of JavaScript, it generally runs it in order from top to bottom. This means that you need to be careful what order you push things. For example, let's return to the block of JavaScript we saw in our first example. Here's the block of JavaScript. Here we are selecting a text paragraph. So the first thing we have to do is grab the text paragraph and assign it to a variable. Then we attach an event listener to it. So we would not be able to do this in reverse order because para has to be defined before we try to add an event listener to it. The update name code blocks. These types of reusable code blocks are called functions. Ask the user for a new name and then inserts that name into the paragraph to update the display with this little prompt method. And also, if you're ever, looking at a code tutorial online and you see them referencing a piece of code, it's very good to Google where that thing comes from. So that way you understand how they're using that thing and really have context of what's going on. So like this thing comes from the window object. The window object is a built-in object on the browser. So if I call console, or go to my console and I call the window object, you get to see the whole window object, which is on my browser. So this window object has something called prompt, and I can call window.prompt. Say hi back. And you see it pops up, say hi back. And then boom, I say hi. The result is recorded as the return value here. And you get to see it in your little console. Cool. All right, let's read up on some complex parts of JavaScript. So all I'm covering is the conceptual part with this section because that's what the homework was for, covering conceptual part. And then during the actual course that we're going to be running, we're going to be doing the practical, doing the actual writing of code. So again, please take the time to read this thing on your own. Come to class with questions, preferably, rather than us reading through these. And let's discuss what you read and make sure we have full understanding. So yeah, how much time left? 5 more minutes. All right, let's see how far we can get in 5 more minutes. Interpreted versus compiled code. You might hear the terms interpreted and compiled in the context of programming. In interpreted languages, the code is ran from top to bottom, and the result of running the code is immediately returned. You don't have to transform the code into a different form before the browser runs it. The code is received in its programmer-friendly text form and processed directly from that. Compiled languages, which we have discussed, C++, Java, and others, on the other hand, are transformed, compiled into another form before they are ran by the computer. For example, C and C++ are compiled into machine code that is then run by the computer. The program is executed from a binary format, which was generated from the original program source code. Does that make sense? The program is executed from a binary format. Do you understand what binary format means?
Yeah.
Jasmine, thank you, Shaq. Didn't know you even popped up. Welcome, welcome, welcome. Jasmine, Angelica, do we understand what a binary format means? No. Okay. Binary format. Let's see. What is a binary format? If you know the word bi means two. I think nary is a reference to number. But anyway, anything that's binary refers to a system of two things composed of or involving two things. The binary number, which is the building blocks of how code is literally zeros and ones. So all code is read from zeros and ones. Correct, Jasmine. All right, so let's go back. So it will compile it into the binary format, which is zeros and ones, which was generated from the original program source code, which means whatever you originally wrote gets transformed into zeros and ones whenever you're doing C++ or C-type coding. JavaScript is a lightweight interpreted programming language. The web browser receives the JavaScript code in its original text form and runs the script from that. From a technical standpoint, most modern JavaScript interpreters actually use a technique called just-in-time compiling to improve performance, which means it will compile it when necessary. The JavaScript code gets compiled into a faster binary format while the script is being used. So that way it can be run as quickly as possible. However, JavaScript is still considered an interpreted language since the compilation is handled at runtime rather than ahead of time. There are advantages to both type of language, but we won't discuss them right now. Let's see, 2 more minutes. All right, server-side versus client-side code. Very important to also understand. These are more complex topics. I'm not going to front, but I think it's good to have a basis. So that way, when we do refer to these things, you start building on the context. So you might also hear the term server-side and client-side code, especially in the context of web development. Client-side code is code that is run on the user's computer when a web page is viewed. The page client-side code is downloaded, then run and displayed by the browser. In this module, we are explicitly talking about client-side JavaScript. Server-side code, on the other hand, is run on the server. Then its results are downloaded and displayed in the browser. Examples of popular server-side web languages include PHP, Python, Ruby, ASP, .NET, and JavaScript. JavaScript can also be used as a server-side language. For example, in the popular Node.js environment, you can find out more about server-side JavaScript in our dynamic website server-side programming topic. All right. Any questions about server-side versus client-side? I think I'll put up a little image too. Server-client model. So the real difference is where the code is coming from, right? Client-side JavaScript is being downloaded on the phone, the web page, or the laptop or your computer, because that's where you're accessing the JavaScript, versus server-side JavaScript that's being accessed by communicating over the internet into the server to get the JavaScript code.
So basically, like, the server is like what hosts the actual website, and then when you use the internet, like it's like satellites pointing you to that server, and you get to download the whatever like the information is from that server, right?
Yes. And at that point, the response will come with the data. and then the web page might display the data however the server gave it back to you, rather than what we have been doing, where we have been developing locally on our computer, and directly from our computer, we have been presenting web pages. Any questions though on the difference between client side and server side? Jasmine, Angelica?
No.
The way that I feel like I'm not too like up on like this, but you probably know more about this one, but like now there's a lot more into like distributed systems where like you will be hosting part of it on your like on the client side as well, if I understand.
Yep, that's kind of how it's going right now, because websites are very heavy. So in an effort to reduce the load, we're following the single responsibility principle to a T, to the point where we even have services on the web server that job is to load a specific part of the data and only one part of the data. So majority of your data can be client side, and then if a user clicks on a certain page, then it might make a request to the server and download some JavaScript code to do something. But there's definitely going to be a mix of client side JavaScript and server side JavaScript, or something else server side, depending on what. But yeah, you generally need a mix of both. Also for security as well, you don't want to have all your information on the front end. It makes it very easy to access, as you've been seeing me play with. I can easily just access everything on the front end by playing around with the developer tools. So yeah, we want to have the separation of responsibility. All right, last thing I'm going to read is the dynamic versus static code. And once we understand those last topics, then we can hop into actual coding again. All right, dynamic versus static code. The word dynamic is used to describe both client-side JavaScript and server-side languages. It refers to the ability to update the display of a web page app to show different things in different circumstances, generating new content as required. Server-side code dynamically generates new content on the server, pulling data from a database, whereas client-side JavaScript dynamically generates new content inside the browser, on the client, on your phone, your laptop, etc., creating a new HTML table, filling it with data requested from the server, displaying the table on a web page shown to the user. The meaning is slightly different in the two contexts, but related, and both approaches, server side and client side, usually work together. A web page with no dynamically updating content is referred to as a static web page. It just shows the same content all the time. And our first project is going to be a static web page where everyone's going to mess around and try and work on a static newsletter. Would an example be only displaying certain content to first-time visitors on a website for dynamic? Yes, as an example. So if we have a first-time visitor, now we have a specific scenario. And because we have a specific scenario, there are cases where we want to display a welcome, thank you for visiting our site, here's a 15% off, versus when we had this person visit multiple times, they don't even see that. That's a dynamic display because it only shows up sometimes. Also known as conditional display, at least in reference to something only showing up sometimes. But anything that's conditional will be dynamic, because dynamic just means it changes. If it changes, it's dynamic. If it doesn't change, then it's static. Once we understand the two differences between those, then we can dive into the real purpose of JavaScript, which is to make dynamic code. All right. Good. We're gonna swap on over. Open up your VS Code, your IDEs, your text editors. Let's get them out. Where is? Oh no, I hate when that happens. All right, I gotta sign in real quick and reinstall my code path. All right. All right, so here is the project that we've been playing around with. Here is the JavaScript file. If y'all remember, we had our variables here. We made generic variables using the var. We discussed how var is able to be used, but it doesn't specify if this variable should change or not. Then there are the declarations let and const. So we can declare the variable with using let. And the cases where we want to use let is wherever we expect the variable to change. Also be called mutable, because immutable means it cannot change and mutable means it can change. So anytime we want to use a mutable, a changing variable, we want to declare it with let instead of var. And anytime we want to make a variable that is expected not to change, we want to declare it with const instead of var. We do not want to use var only because var is not explicit enough. And this allows the developer to understand that, hey, this variable was made to be changed. And hey, this variable was made not to be changed. Do not overwrite this. Any questions? On
No.
all right, good to hear. Also, I forgot, I can't see the chat. All right. Then we have constants. Constants are the same as variables. They are more so about programming conventions. So again, as a developer, when I'm quickly reading something, the way I differentiate what's going on between all these things is the conventions we follow. Using this convention lets me know that this is mutable. Using this convention lets me know that this should not change. And using the all caps convention lets me know that this is a constant in the file that I'm working on and that this value should always be this value. So max retries should be constantly 10 unless I change this for whatever reason to 5 or whatever. But like anywhere that this is being used in the code, I know that it's being referenced to one place, and that one place is going to be an unchanging value. It's not going to get dynamically updated by JavaScript. So there's not going to be a function here that says turn max retries into 10. Default text is another example of that. This does not really matter if it's default text like this. This still works. The computer doesn't understand the difference. This is simply for developers to understand that, hey, this thing should always be that value, and it should not be something that's being dynamically updated. Does that make sense? Any questions on that? Okay, good. All right, and then arguments. Before we discuss arguments, we actually have to discuss functions. Oh, I can't cut this. Also, make sure y'all writing these down for your notes. A function is behavior. It's really just behavior. It contains an inner scope. So here is the inner scope. And in the inner scope, we define what the thing does. On the outer scope of the function, we define the name of the function and its arguments. So an argument and a parameter is the same thing. Right here, we have the parameter custom text. And we are assigning that parameter to default text whenever it's undefined. So if custom text, actually, I don't want to do that. If custom text is undefined, it then defaults to default text hello world. And we tested that before. And let me test it again real quick. Yeah, hide this. Did not work. What's happening? Large Chrome against local. It is not liking it. Oh man, I forgot. What's the other ways to run this? Oh, I know why. I'm running the wrong thing. I gotta run this file. This is not my HTML. Let's see here. Oh, it's not liking me today. All right. Run index HTML on localhost. I don't really like doing the HTTP server way, but we're gonna do the HTTP server way. And run HTTP server. All right, so I gotta navigate to my index.html. What's in here? Coding course. Let me see here. Go to your browser. All right, cool. All right, so now we're back here. If the debugger doesn't work for you, you can always install what I just installed, HTTP server. Let me know if y'all need HTTP server or if y'all can run your local branch without it. I'm gonna lob this in the chat real quick. Where is Zoom? Always forget to get back in here. Honestly, I shouldn't even send the whole thing. You really just need to run this. And then run this command wherever your index.html file is located. For me, it's at the root. Should be at the root of your folder too. Everyone got their local host running? Please have your local host running because this is interactive. We're going to be following along, doing things, and get the muscle memory, get that practice, get that muscle memory practice. All right, Angelica, you got your local host running? Yes, no. Jasmine, yes, no. Arnelia, I know you have no power. Welcome to the class anyway. I need to hear y'all speak up so that way we can move on to the next part of the class. We can't move on to the next part of the class unless we're prepared.
I don't have it because I didn't bring the right computer, the laptop, so I don't have the computer with the programs. But I am paying attention, so you can move forward.
Okay. How about you, Jasmine? What's the word? Do you need help getting your local host set up? Not yet. Okay. Do you want to share your screen so we can work through yours and get you set up? Jasmine, would you like to share your screen so we can get you set up on your local host? Do you have your IDE? As long as you have an IDE on your computer, you should be fine. If not, if you don't have an IDE on your computer, I'm gonna assume not yet means I don't have an IDE on my computer. So Jasmine, Angelica, what y'all are gonna do is, y'all gonna go on CodePen. Yes, I am a human being. Thank you. All right, so I need y'all to go on CodePen, right? Saturday, we're gonna discuss making sure everyone's set up. So I'm gonna set up a meeting with y'all because that should be done. That should be done. So for today, y'all are gonna go on CodePen. Feel free to write some HTML here. The HTML that y'all gonna need. We're gonna do some real basic HTML. I don't think y'all need a head on this. I think y'all could just go with the body. So you're gonna pretend that you're only in the body section of your HTML. I want y'all to write the header. Get a header in here. You can get a nav bar in here and one p tag. My first paragraph. All right, so let me know when y'all are on CodePen. Make some A tags. When you get on CodePen, you're gonna write out your header. give it a class. Get your H1 tag and your H2 tag underneath the header, and then write a nav. Put a unordered list in your nav, and then in the L1, each L1 I want each L1 to be a anchor. Let's just say home. And then we're going to copy that. And let's say account. All right. Are y'all on CodePen? Have y'all successfully made it here? All right. Have y'all remade the HTML?
Typing it now.
All right, cool. So remember, just a header, a nav, and a P tag, a paragraph tag. So those are going to be the basic structures we're going to play around with. We're not really going to do any CSS. I'll make this disappear. We have. I don't know how to make it disappear. There we go. All right, so we're just going to be playing around with HTML and JavaScript for today. All right. Let me unload this for y'all. Header, H1, H2, header, nav, unordered list, list item, anchor tag to home, list item, anchor tag to account, close the unordered list, close the nav, and then write a paragraph with my first paragraph. And also let's add a button actually. Let's add a button. We're not going to close it. The button is going to be called Click Me. I'm going to just space these out so that way it's a little bit easier to read. All right, so this is what we're going to be playing with. It's 7:53, so we're going to hop on over to the Udemy course, and then we're going to be following along with the Udemy course, but along on the JavaScript side. Everyone's ready, comfortable, good to go? Angelica?
Yes.
Yeah.
All right, good. All right, boom. Let's start it up. Let's see. Let's review what we got going on here because we have an hour. We're going to work with functions. We did the last class declaring variables, looked at user interaction. I'm going to be going through functions, code functions with return calculations, conditional statements, switch statements, and I think that's going to be all that we have time for. But all of today is going to be functions. So expect to be working on functions. All right, let's go. Let's get it started.
Leaving it like that is optional. So now before, and again, to illustrate what's happening here with the code, the browser's rendering out the JavaScript. It hits a way to pass values through, and we're actually not going to be using this initially. So
I'm going to be doing it in CodePen with y'all. Need a good way. I'm going to start with function, my function.
those functions are a piece of code that runs here. So we could do something like console log, and we're going to use that console log again, and hello. And this is all that our function is going to do. Maybe we can also have a increment there. So every time we call out to that function, it's going to write out to the console and it's going to do hello. And I'm going to do a plus a. So every time we call my function, so instead of what we had before where we kept calling out to the console log, I can simply do my function. And I'm going to actually add that a bunch of times here within the code and go back out, refresh the browser, open up our console. And we see that we're actually calling it out a bunch of times. Something went wrong there. Because we had called a here. So that's one of the things that we're going to look at as well. So the reason that didn't work is because it was expecting a value and is assigning a value to a, and then we were incrementing a. So we would have to have, we could pass through a number here and it would actually increment a. So show you how that works next. We're just going to refresh that. So get that working first. So now we've got 1, 2, 3, 4. And again, to illustrate what's happening here with the code, the browser's rendering out the JavaScript. It hits variable.
All right, thank you. Well, thank you for breaking for me. If you go to your console right here at the bottom of CodePen, you'll be able to see exactly how this code is being ran. The code will update as you type into it. So if you write my function 1, 2, 3, you pass along 1, 2, and 3 as the parameter or as the argument. It'll increment right here. This line is where it increments, and then it'll log out in the console, hello, plus the incremented value. So as you can see, it goes 2, 3, 4. Copy this. Write this up. Saying it should save and then go to 1, 2, 3, 4. Hello, 1, 2, 3, 4. If everyone is able to get to there at least with writing your function and logging it out into your console, then you have passed the first step of writing your own function. If you have not gotten there, if you're struggling to see it or struggling to invoke your function as I'm doing here, here, and here, please let me know so that way we can figure it out. So everyone here, got your function written, got it logged down the console. Angelica, Jasmine, need a second. No problem, take your time. No problem, take your time, take your time. I always recommend copying and pasting. Once you name your function, it's very easy to just copy, paste it, and invoke it by adding some parentheses and then doing something with it. Yeah, the first step is writing down the function definition, and then invoking it is super easy, copying and pasting. And while we're here, I'll talk about something, right? So I know we talked about JavaScript reading top down and how generally we don't want to assign something before it's been defined. If you have TypeScript or some type of linter, something that pretty much checks your code, it will warn you against following this direction and will recommend doing this. Where
Somebody said if you could show the HTML code again for a second.
Oh,
I'm
no
bad, I didn't mean to cut you off.
Oh, no, you're good. I appreciate it.
Thank you, Skill. I'm good, thank you.
No problem. Essentially, we're going to be playing around with the button. We're going to be adding on click. I forget how it went. On click, I think it's $. And then my function. Well, it didn't break. If someone broke. Expected token. Maybe something like this. And a 1. Oops. All right, we'll figure it out in a second. Am I done with the HTML? Can we go back to JavaScript now?
Yeah, thank you.
No problem, no problem. I'll look at my button and see how I did it. On click, create alert. Oh, I didn't put the $sign. All right, so I'm getting my JS. I'm getting some other stuff confused. My function. Cool. There we go. All right, so this is going to be implementing the JavaScript onto the page. So once you have your JavaScript written, you have your function definition. You can invoke a function before it. It's technically not the proper way to do it, but this code is it doesn't really care. It's synchronous. All right, so everyone has their function definition written. We're comfortable seeing it in the console. Jasmine, Angelica.
Yes. What?
All right, cool. All right, Jasmine, let me know. Are you comfortable seeing it in your console? Do you have these logged out?
I think I need a little bit of help.
All right, that's fine. The sooner we get the help, the faster we can move forward.
Yeah.
So I'm gonna let you share your screen. Give me a second. Stop sharing. Share screen, multiple participants. All right, share your screen.
Okay. Here we are. Can you see this?
Mm-hmm. All right, so we have your e-learning website. You got the head one. All right, you got your nav. You got the link to home. Let's add another one. Let's add a link to I guess account. Let's call it account. Copy and paste the first one. So this is how you're gonna learn how to the first link, LI line 6. So we're gonna add another link, right? And we're gonna call it account instead of home. So this is how we speed up our development process. We learn how to copy and paste.
Right. Okay.
All right, now you have your button, click me. Cool. All right, now let's go to your JavaScript. Right there in the third tab. So we can close out the CSS tab. If you go a little bit over to the right, yeah, you see that? Minimize it. Just pull it, drag that down.
Got it.
All right, cool. So we're not going to be working with CSS today. All right, so we're going to type something called a function. So we're going to write function. We're going to just call it my function for now. So space and then my function. Make it one word. Perfect. And we're going to do something called camel casing. So camel casing, if you think about a camel, it has humps. So it starts low and then up, then low and then up. So camel casing, we're going to start with the first letter being lowercase.
Okay.
And then the next letter that starts a word is going to be capital. So we're going to turn my function into a camel case convention. So the first letter, just the first letter, is going to be lowercase. And then the second letter, no, not the second letter, the second word is going to start with a capital letter. So exactly how you wrote it is correct. This is called camel casing.
Okay.
All right, now we're going to Now we're going to continue. We're going to put parentheses. Yep. And then after that, after the parentheses, well, actually, no, while we're inside the parentheses, we're going to add a parameter or an argument. And we're going to put the argument as A. All right, now we're going to define the inner scope of your function, which is going to be the behavior of the function. So to start to define the inner scope, we first have to create the boundaries, which is going to be curly braces. So right after the A paragraph tag is over, or not paragraph, parentheses, make your curly braces. Do you know what the curly braces are?
No.
Right next to the letter P, you see the curly stuff? There you go. So those are curly braces, also called curly persons, curly boys, and probably a whole bunch of other terms that I do not remember.
Mhm.
So press enter. Now we are inside the scope of your function where the behavior is being defined. So for your learning purposes, type, I want you to type this, get it from the chat. This is going to be adding a comment to the JavaScript. So that way we remember that this is the inner scope of our JavaScript.
I can't exit out of, hold on 1 second.
If you press escape, you can usually get to your chat.
I was in my chat and it wasn't letting me exit. Okay, so.
Boom. So this is a comment. Anything that starts with those 2 forward slashes are comments. Everything that comes after are comments. So comments do not affect your code. It's literally just for you or other developers to know what's going on. All right, now we're going to press enter again while we're in the inner scope. The first thing we're going to do is we're going to increment A. So we're going to say A, and then we're going to put a plus plus. So this is going to increment the value of A and make it go up. Then the next thing we're going to do is we're going to call console.log. So enter again, get a new line of code. And on this new line of code, we're going to log out some information to the console. So type console.log, console.log, and then parentheses to invoke the function because console.log is a function. And then we're going to type hello in parentheses. So put the hello in parentheses. You can just highlight it, double click it and highlight it. Just the hello, just the hello. Double click the hello. Yeah, that's a faster way to highlight a small section. All right, now press the parentheses, not the parentheses, the what is it called? Apostrophe? Not apostrophe. Quotation marks.
Okay, got it.
There you go. All right, so this is a string, right? So now we're going to log out a string called hello. Anything in the quotation marks is a string, but not only do we want to console log out hello, we also want to console log out what the A value is. So we're going to say hello plus the A value. That has to be inside the scope of the console log, or else it's not going to work. So the scope is defined by the parentheses. So we're not affecting the string. Yep. Continue. Yep. All right, now let's add a space. Actually, no. First, we're going to go to your console. So if you look at the bottom of CodePen, there's a word that says console, bottom of the page, all the way down.
Right here, console.
All right, so pull that up. All right, clear it because it has a lot of errors. All right, now we're going to click in on your code, JavaScript code. All right, and then in the hello, put a space between the pluses. Make it a little more readable. This should also update your stuff. All right, so now at line 5, press enter again. After line 5, like outside the scope of this. Now we're going to be invoking the function. So press enter again. Create a comment that says invoking function. So to make the comment, / twice again.
Oh, okay, got it.
And now we're gonna say invoking, INVOKING function. So invoking means calling, which means making this thing actually run. So from line 1 to 5, all we did was define what the function does, but now we're gonna tell it to run the function. So call my function. So copy the name at line 1, just the name. Double click it also for faster development time. Paste that. All right, now we're gonna invoke it. So to invoke it, you have to use the parentheses. So just type some parentheses. Let's let that build right now. So you see right now the console came, it says hello NaN. NaN stands for not a number. It's because you're invoking it with nothing inside of it. So let's invoke it with a number. So now let's put 1. It's gonna update hello 2. Boom. Let's put a space between hello and the last quotation mark. Between hello and the last quotation mark.
Oh, okay.
Yeah. That way it says hello space 2. All right. So now that you're here, you have successfully created and defined a function, and you have successfully invoked or called the function. Now, the final step is making the button invoke the function. So we're going to go back to your HTML, and in button has a method called onClick. So if you go into the button element, right where the N is for the button element, the N, press space. Now we can type out some methods that exist on the button. So the onClick method is the one we're calling. So call onClick by just typing it out. And now we're gonna press equal. So that way we can assign the method to do something. And now we're gonna put quotation marks again. Since this is HTML only knows quotation marks and whatnot. And then we're gonna call my function is camel case. This is why we copy and paste. That way we don't have human error. And then we're gonna invoke it. So every time this thing gets clicked, it's invoked. So invoke it with some number, it doesn't really matter. All right, cool. So now go and clear your console. And let's see if that worked. Bring the console down. We got to go back to the actual web page. Just the console. Clear. Press the X.
Okay.
All right. Click the button. And now check your console. Hello 3. Success. You have written JavaScript as a function. You've invoked it. And now you have your HTML, the structure of your page, referencing your JavaScript file for the behavior of the page.
Okay.
All right, so kind of see how it's all coming together.
Yes, I see the connection.
All right, now you can end your screen share. We're gonna continue and build on the functions that we're running through from this Udemy course. While we do that, we're going to define in our JavaScript file and constantly follow along using console, the fake browser here, and our JavaScript and HTML here. All right, let's go again.
Leaving it like that is optional. So now every time we click this button, we should see that hello, that function is being called and it's being reused. So functions are great for reusable code. And as well, you can call them at any time. So over here is
let's do something real quick, right? So let's practice our variables real quick. We're gonna make a const called initial value. And we're gonna initialize it to 0, right? And then we're gonna say initial value. I'm gonna just copy and paste this rather than type it out. Initial value plus a and incremented. Let's see if that works. Let's see if that makes a so 0 plus 1 obviously should be 1. 0 should not really affect anything. Let's see though. Click me. Hello 2. What happens if I click it again? Hello 2, hello 2. All right, so what I want to happen is I want to see it dynamically update. I want this to be an incrementing button. So what we're going to do is we're going to actually increment initial value. And instead, we're going to say let initial value equal 0. That way, initial value can update every time. And if we pass in a parameter of a is also going to get added on top of initial value. So we're going to say a plus initial value incremented. And then we're just going to actually, we're going to describe something here. We're going to say const final value equals, you're good, a plus initial value. And then we're going to console log it all out. Teaching a class. Close the door. Thank you. So this way, I'm gonna take out this. I need to see that over and over and over. So this way, it starts at 0. And hopefully now, every time I click this, I don't have the ability to. I'm gonna just click it a few times. So now every time I click it, it increments. Starts at 2, 3, 4, 5, 6, and keeps going up, up, and up. All right, so now that we have an incrementing button, if everyone has an incrementing button, we're good. If you do not have an incrementing button, we're gonna discuss why, right? So the first thing we did here was we set initial value to 0. We declared it as a let. Why? Because we want this value to update. If we declare it as a const, what happens? This thing complains. Attempted to assign to read-only property. See, it's complaining because this cannot get updated unless this is a let. So we have our final value. Our final value is going to be whatever a is plus initial value incremented. So if a does not even get set, if a doesn't get set, initial value is always initial value. Another way we can do this, we can even say initial value equals a, and then final value equals a plus plus. So the reason I'm doing this, initial value equals a or 0. So right now I'm really showing y'all ways to make this thing really safe. Another way to do this is initial value equals a equals 0. I'm gonna show you both just to give you all examples of ways to make this code safe. So we have our initial value 0. We have A. If A is undefined, it gets set to the default value of 0. Then we redefine initial value to be equal to A. If A is undefined, it'll get set to 0. So this is obviously a over-engineered solution. The best way to do this would be to take this all out and instead say, I'm kind of partial on this. But I would prefer having 0 be, a value reference outside. And then we actually have this be set as a default. That way we have 2 places. Right now we have 2 places that would be setting it to 0. A will only be overriding it if if A is passed in. If A is not passed in, we start with the initial value of 0. Otherwise, if A is passed in, it overwrites the initial value. I'm about to get this dog out of here. 1 second. But again, JavaScript is the wild, wild west. And because it is the wild, wild west, there are multiple ways to do this. If you chose to do this way instead of doing it this way, this is also still correct. And if you chose to do it by writing initial value plus this will also be fine, only if you set A as 0 as this default value. Otherwise, you might have come across not a number where A is undefined and you have issues. So either way, we have to have some guard case to make sure that this does not evaluate to not a number. Let's move forward. What is this complaint? What is this talking about? Cannot find variable initial value. I definitely wrote that wrong, which is why we copy and paste. Now I'm like, did I spell initial right? Anywho, I'm assuming we're all caught up here. I want to read the chat. Okay. Nothing in the chat. So I'm assuming there's no questions on this. Everyone should be able to click their button and see this thing increment. How did I screw this up? Oh, it's because my incrementing is on the A and not the initial value. So this is a good lesson to talk about scope, right? Initial value has to be outside the scope of this, because every time this function gets ran, whatever is inside the scope gets rewritten. So every time this is going to start at its default default. Everything inside of here is going to be recalled every time the function gets called. But the value outside of this is going to be set outside the scope of the function. So every time this function updates this value, even though this is getting reset to back to 0, the initial value will not be getting reset back to 0. Because of that, I'm going to write A plus, because this is a little hard to read, but A plus the incrementing initial value. If I click it, you see it increments 2, 3, 4, 5. 2, 3, 4, 5, 6, 7. All right. What time is it? 8:25. All right, we're definitely not going to run through as many things I wanted to, but hopefully we're getting a thorough understanding of the function. Any questions before we move forward? All right, we're moving forward.
Leaving it like that is optional. So now every time we click this button, we should see that hello, that function is being called and it's being reused. So functions are great for reusable code. And as well, you can call them at any time. So over here is leaving it like that is optional. So now every time we click this button, we should see that hello, that function is being called and it's being reused. So functions are great for reusable code. And as well, you can call them at any time. So over here is.
Why is it breaking every time that one part?
Leaving it like that is optional. And as well, you can call them at any time. So over here is.
Oh my gosh. Udemy is making itself look terrible.
Value, a variable is declared outside of the function, it's globally accessible. Meaning that, as we saw in the example, that A is 0, and even within that function, we see that this is what the value of A is. So if we were to do something like variable B equals hello, and we console log out B, and then we also console log out B over here. So first of all, do you think this is going to work? So logically, we're just going to look at how this is rendering out. The browser hits this JavaScript file. It's going to start reading through it. It's going to say A equals 0. It's going to run the my function. And in my function, we're declaring B has a value of hello and A increments there. So all of this stuff, actually, we could probably even get rid of that to avoid confusion. So over here, we've got this console log of B, and it's actually, it's not declared, but in order.
Let's rework our function to make it more similar to his, right? So we have let initial value equals 0. We can keep that. Function, my function is no longer going to take in an argument because he's not putting an argument. We're going to have var b equals hello. We are going to have the console log of B. So that's what we got going on here.
So the function runs this, and we're declaring B within the function. So do you think that we're actually going to see that output of B over here? And we should just.
So he wants us to console log B on the outside of our scope of the function scope. So what do y'all think is going to happen? I mean, y'all already see it's happening. Can't find variable B. For obvious reason, we're outside the scope of where B was defined. B was defined inside the scope of the function, so it's only accessible inside the scope of the function. The same way how initial value, well, not the same way. In the inverse, I guess, initial value is set outside the scope of the function, and because it's set outside the scope of the function at a higher scope, and this is an inner scope, we can access it down here because it's accessing it from outside its own scope. So everything inside of it, it only knows what's inside. Everything that's inside of it, it only knows within the function. Everything outside the function scope is accessible by everything else. Does that make sense? Angelica, Jasmine, that makes sense?
Yes.
All right, cool.
differentiate as well. So do you think that this console log B is going to actually be able to return hello? And now we'll go out and we'll just check and see what happens. And as you can see, whenever this page loads, we get that B is not defined because B is not a global value. It's only usable within the function. So that's why when the function's calling B, we're able to access and use it, but outside we're not able, there is no B value. And so with functions, we can also pass values. So I can use something like C, and I can pass over this value of C So now when I call my function, I'm actually going to pass this value of C into the function, and I'm going to output it within the console log. So going back out here, refreshing it. When the page loads, the function is going to run, and we see within the function hello. So we're able to access that value within the function, and we're able to pass over different values. You can have any number of values. So maybe we could do it like this, C, and with string values, you got to always quote them. Otherwise, it's going to take it as a variable. And this again goes back to why we have to have variables declared, because if I do something like this, it's going to think that there's a variable called hello. It's not going to be able to find that, and it's going to produce an error. So that's why we have variables that get declared, and we have to quote out string values that aren't variables. So we could pass through a variable in this fashion if we wanted to, but if it's an actual separate string, a brand new string, we pass it through within this format. So I'm going to just add in some, so we can actually see some additional code. And these pluses are just concatenating the content, and it's just adding a bunch of spaces here. And again, going back to that initial point, why we can't start a variable with a number, because as you can see here, we don't have to quote out numeric values. It's only going to be for string values that we have to quote that out. So over here, we're going to be passing hello, 10, and 100. And now we're going to write out these values. But because within the function, we're redeclaring hello, so maybe we'll do hello 2. What do you think this output is going to be? Is it going to be within a function? It's going to be A. So A would equal hello. B would equal 10 over here, but then it would be overwritten by a new declaration of B within it. So it would be hello, hello 2, and 100, or would it be hello, 10, 100? What do you think the output is going to say when I run this function?
All right, cool. That's pretty much all we really need to learn from this part of the course. So I went and messed around with what he was doing here. Let me hide my floating controls. And so as you can see, I added 2 more arguments and changed the first argument to C. So now we have 3 arguments, C, D, E. Inside of this, I wrote var B equals hello. We're also gonna write a var B over here equals goodbye. So that way we can see the precedence of scopes. And then also we're gonna console log out goodbye. I mean, not goodbye. We're gonna console log out B. And one convention I like to do is make it an object. When you make it an object and you put the B, it'll make it the key and the value pair. So as you can see, I have B and the value is goodbye. So we can see that B starts out with the value goodbye. But at the end of it, it becomes hello world with 000. That's what's being console logged out. So whatever in the closest, whatever is closest to the return value is going to be the final thing that we see. So this is overriding that. But if I did console log B over here, what happens? Actually, I don't even want this because that will be confusing. So we're going to have one that's just that. So my console not gonna update. All right, let me click the button. Hello one, undefined, undefined. Cool. How do I get you to update for me? Why are you not updating? Let me see. There we go. All right, so now that update, you can see the 3 we got was B, goodbye. That's where we started with. Here we have B equals hello. We console log that out. We got the hello world with the zeros. And then we also have the final console log of B, which is still equal to goodbye. So as you can see, the scope matters. The scope matters. Only within this scope is B equal to hello. But everywhere else, B is going to be equal to goodbye. All right, now that we got that out the way, we can also talk about the difference between these 3, right? So this value is a number. This value is a string, world, and this is a variable. The way we know the difference is, well, 1, this is obviously a number, but if we put this in quotation marks, this would become a string and no longer a number. This is only a string because it has the quotation marks. If we took the quotation marks out, it is now a variable that has not been defined. And this right here is a variable because it has no quotation marks. If we put the quotation marks, it is now a string, and we no longer get hello world 0. Instead, we get hello world initial value. So understanding our data structures, our most plain data structures and data types, is how we understand what values we are passing along to our function and make sure we are correctly handling the data rather than getting broken information like this. So remember to put strings with quotation marks. Remember, numbers must be numbers. Decimal marks works, but it must be a number. Once I do ASS, it no longer is a number and it doesn't know what I'm typing. And variables must be defined. All right. 8:38. Let's see how much time we can get through. Let's see how much we can get through. Any questions? Any questions before we move on? I see no questions in the chat. I know we've covered the same topic kind of over and over and over with a lot of different examples, but that's because JavaScript has so many different ways to do the same thing. So please don't mind the repetition and try to understand the differences as being preferential more so than anything else. All right, any questions? No questions. I'm gonna move on. We're gonna use the last 20 minutes to see what else we can cover.
I do
No
not
questions.
I think someone said they had a question. Or was that both 2 no questions? I think that was 2 no questions. All right. Let's see here. We done with this.
And we see that, in fact, that in return values, so you can do calculations with functions. And we're going to be getting into that in the upcoming lesson.
All right, let's get into it. Return values. So we've been playing with console logs the whole time. What is a return value?
So in this lesson, we looked at what we can do with functions. So now we're actually going to create a brand new function. And I'm just going to call it add. And I'm going to expect a couple arguments. So I'm going to have A and B. And hoping that they get passed, expecting them to get passed through. And so now what I'm going to do, C equals A plus B. And another thing with JavaScript, you can do calculations. So A plus B, A minus B, A times B, and so on. So actually, maybe we're going to do A times B to make it a little bit more interesting. And then Also within a function, if you want to get these values returned back, so we saw in the previous lecture that we were setting a value of b, but when we declared that value, we could only actually access that value within b. And so if you wanted to actually return back a value, so we could do a variable c, almost forgot to declare that variable. So we can return back c. So what this is going to do when this function gets run, it's actually going to return back a value of c. So this gives us another way to do functions where we could do add me. And all we have to do is put in a number 7 and 8. And just like the other functions, we can just reuse this over and over again. So I'm going to put some bigger numbers and some other numbers. And so what it's doing, it's actually returning these values. And we're actually not going to be writing them out. So we have to console log out these values. This is the same thing as using it within our code. So if we were writing these out, we could also do document write and we would get these calculations. But for now, what we're going to do, we're just going to do it within the console, go back out, refresh our page. And we see that JavaScript performs these calculations. So in the first.
All right, so we don't really need to rewrite the console log. I'm gonna utilize what we did here, CDE, and just pass in add me. So we're gonna say a few ways we can do it. We can pass this directly into here and console log out what we're getting. 0, 0. So you see that we get 15 and then 0, 0 is being here, or we can turn these into empty strings. That way they don't affect us at all. Then we get hello 15. Cool, cool, cool. The other way we can do it is declaring this as a variable, const c. And then we can again call my function. Oops. And instead we can pass in C and then the 2 empty variables. So now we get hello 15 and hello 3. Hello 15, hello 3. All right, let's continue on. Everyone has the add me function and you're able to see the value change. Now we're having 2 functions. One is to get the variable for C, and then my function is literally just to log it out. Everyone feel comfortable with this? Y'all still here? Jasmine, Angelica?
Yes.
All right, cool, cool, cool. All right, let's continue on.
First one, we had 7 times 8, returned the value of 56. The other one, it was.
No. Don't start this up again.
So I can do 9 times 9. And I should get a return value of 81 from the JavaScript.
Yes, we can also call these functions we define in our console. 1 and 1. And we'll see the value get returned.
Function. So this gives us the ability to start really energizing JavaScript and get working with JavaScript returning back values. So this won't work well if we've just got it here because we're not actually, so even if I was to do here, and if I pass 5 times 5, just show you what happens. So do you think this is going to work? If I click the button, I'm passing 5 and 5, and I'm clicking it, but I don't actually see anything happening. And that's because we're not actually outputting it anywhere. So that on click is doing actually going through and running this function, but we're not seeing anything happening because we're not outputting anywhere. We're just returning that value of C, which doesn't mean anything within that click value. So we could console log out C, or we could document write it. So maybe we can just do console log. So you have to always make sure when you're using return and you're using it in this fashion that you're actually able to actually see the function get performed. Or if you just wanted to have a simple calculation and have maybe another function that outputs it into the console, so we could have an incrementing value. So maybe we're just going to do D. And every time it gets clicked, D will increment. And now we're going to do times D, just plus D. And we're going to console log out D. And also we're going to do C. And maybe just to be exact, we'll do a D equals here as well. So now when I click the button, what do you think is going to happen? Whenever I console log it out, we see that D, because it's a global value, it's incrementing. And even though we're still passing 5 and 5, our calculation is incrementing because this value of D, this constant global value of D, that we're not redeclaring a new value for it. So it is actually incrementing globally. And again, this is a great way to do some calculations using JavaScript. There's quite a bit here to work with and a bunch of different operators that you can use in order to interact with JavaScript. So I encourage you to try this out for yourself, pass various values to functions, make some different calculations, get the return on the calculations, and see what you can get JavaScript to do.
All right, super short, super simple. That's the return value. The difference between console log and return value, console logs return undefined rather than the return value. As you can see here, the return value gives us the actual result back to us. This allows us to manipulate the value and pass it along to other functions. But if addme had no return value, right? In this example, we have addme 78. If it had no return value, if this was commented out, we get hello undefined because console log itself just returns undefined, but C is still getting console logged out as the result of the two things. So if I do this, you'll see C is still getting console logged out as the value of 3 and 15, but hello from my function call is getting resolved as undefined, because this is undefined, and undefined plus 2 empty strings is still going to give you undefined. C is resulting in undefined. Log. I know this is kind of over engineering to see the same thing, but just so that way you can see it. Here's an empty object, and here's our console logged out 3s. Clear this out. All right. So the key point is to remember is that return allows your definition to be defined, and when you return it, that value is passed along to whatever thing references it next. That allows us to assign the return value to variables, along with passing that return value to other functions, as we've done in my function here. With those things covered, let's see here. We have conditional statements, but we're not going to dive into the rest of this yet. Instead, what we're going to do is we're going to discuss the next project that y'all are going to be working on and which groups y'all have. All right. Stop share. All right. So I'm going to stop the recording for now.